So following on from the previous video, we used the absolute convergence test in the previous video, and it didn't really help us. So now we're going to use the alternating series test. So we are trying to determine if this will converge or if this will diverge. Well, let's try the alternating series test. So with the alternating series test, they're asking you to isolate this, extract the UN. So they're asking you to isolate this and just extract the UN. So this here is our UN here. So just extract this and ignore this alternating thing. So ignore this alternating thing. Just look at the UN. Just look at the UN. So this is our UN here. It's saying make sure all the UNs are positive. Well, in the round from 2 to infinity, this will always be positive because natural log looks like that. This is 1 here. So 2 beyond 2 is always positive. This thing here will always be positive, making the whole thing always positive. So all the UNs will be positive. So condition 1 is good. Okay, it has been satisfied. Condition 2, make sure it's always going downhill. Make sure that make sure it's non-increasing. Make sure it's non-increasing. So it could stay the same. Just make sure it's going downhill. So this is our AN. Sorry, this is our UN plus 1. This is our UN plus 1, and this here is our UN. So it's just saying make sure the next term is smaller or equal to the current term. So make sure the next one is smaller or equal to the current one. So basically, make sure it's always going downhill. So to do that, let's map a continuous. Sorry, hang on. So this is our UN here. We need to make sure that it's always going downhill. It's non-increasing. Make sure that the next term is smaller or equal to the current term. Make sure the next term is smaller or equal to the current term. Well, looking at this, at the moment this is discrete. So let's map a continuous function on top of that. Let's look at this function. We're going to map this continuous function on top of that. So looking at this, to make sure it's always going downhill, we would look at the derivative of this, or differentiate this. It will then give you this. Tidy up, it will then give you this. So now in the round from 2 to infinity, this thing here will always be positive. This thing here will always be positive. The whole thing here will always be positive. But then, so the whole thing here is always positive. But then you've got a negative here, making the overall thing negative, because this whole thing here will be positive, and then you've got a minus here. So overall, it will be a negative. So this means that our gradient is always negative. What that means is it's always going downhill because it's always negative. So going back to here, we are trying to investigate this. It's saying extract the UN. This has been satisfied. Now this has been satisfied because it's always going downhill. The gradient is negative, so it's always going downhill. It's non-increasing. So condition 2 has been satisfied. Now for condition 3 to be satisfied, we need to make sure that the limit of UN, the limit of this, heads towards 0 as n heads towards infinity. So limit as n heads towards infinity of this. Well, you can see that this will head towards 0 because this is just going to get bigger and bigger and bigger. This is going to get bigger and bigger. Multiply the two things that are getting bigger and bigger. 1 divided by the limit will be 0. So this has been satisfied. So the theorem is saying that this series will converge if all 3 have been satisfied, or all 3 have been satisfied. Therefore, this thing here converge. Okay. So so this whole thing here will converge.